4th of July, 1955. This training field is on a 24-hour alert. Airplanes are ready to go. Pilots are ready on a 5-minute standby. Here's one of the reserve pilots, Lieutenant Bob Marshall, married, one son, born 5 days ago, a healthy 7-pound boy.
How are you, Rudy?
Hi, Bob. How are you? Hi, Bob. How's the family?
Fine. Coming home from the hospital this afternoon. Boy or girl? Boy. Bobby Jr. You know, I was just thinking, when the little guy is grown, this country will be 200 years old. I was just wondering what kind of an airplane he'll fly. You know, will he sit in it or be down here with a box of push buttons?
Probably the box of buttons. Yeah. Look what's happened just during our lifetime.
That's what I was just thinking about.
Well, don't worry too much about it, chum.
Don't worry about it. It's my son, isn't it? I wonder. They talk about the good old days. Nothing flew but the birds.
Would you like to go back? Would you, Bob?
You mean to the good old days?
That's right. 50, maybe 100 years ago. Say July 4th, 1855. Would you really like to go back?
Well, yeah. That is, if we don't have to scramble. Nothing to do but sit here and wait. Yeah. I'd like to see what the country looked like 100 years ago. Why not?
Well, to give you a chance to get used to things, look around, Bob. Use your imagination. No airplanes, so no pilots.
This.
No electronics, no electricity, no scientific gear, no modern comforts of any kind. No telephones, no plumbing. Take a look at the good old days, Bob. 100 years ago, of course, babies weren't born in hospitals. Doctors were few, and your son would be born at home, probably with the help of a woman in the neighborhood.
Hey, he's crying. What if he's sick?
Well, you can go out and try to find a doctor.
Try to find?
Bob? Bob!
Hey, that's Ann. That's my wife. What's the matter, honey? Is he sick?
No, I don't think so. Would you bring me a drink of water?
Sure. Sure. Right now. Wait a minute. No running water.
No, but there's an open well outside.
A well?
You can go dip some water from the well.
Dip some water? How do I know it's safe?
You don't. But you don't have to worry about it. This is the way things were 100 years ago, Bob. Hard to imagine, isn't it?
Yeah. For a minute, I almost forgot. Gee. A simple little thing like a drink of water. You know, I can't imagine living like that. Why didn't somebody do something about it?
A lot of people were trying, Bob. The industries that could do something about it were just being born. Ever since the 4th of July, way back in 1776, the atmosphere of the United States had been charged with a kind of electricity that sparked the human spirit in a way that has no earthly precedent. We could work and worship as we pleased. We could try a new idea. A man might be poor and unknown in a strange city, but he was free to try. And Bob, the story of countless trials like this is the story of America. July 4th, 1855, a young man, Richard Teller Crane, is declaring his independence. He's alone. He built this foundry with his own hands. He made his molds from sand dug up from behind the building. He's about to pour his first castings.
Kind of a one-man operation.
But think of the opportunity. He's in a city of 75,000 people. There are 20 million people in the whole country living without the comforts and conveniences that you take for granted today.
I don't see how one man could do very much.
Not if he kept on doing everything by hand. But people need what he can make. Soon his brother will join him. Then there will be 2 employees. The little business will grow as America grows.
I still don't see how you could do much working with your bare hands.
That's right. That's why the pioneers had to learn to build and use machines. His first machine was a lathe, but he had to supply the power.
A foot treadle. What kind of power is that?
This is pioneering, Bob. But the long rise and development of power had begun. Slowly, the ancient arts of handcraft could develop into modern mechanization. It was a historic interplay of necessity and invention. You see, the pioneering served itself. The machines produced parts for better machines. Valves and piping materials could produce more powerful steam engines. Each improvement pushed up the standards, required more metal, tougher metal, better machines. A new technology, new standards, and new controls began to grow because America couldn't grow without an increasing supply of the basic products. In 1858, just to build a county courthouse called for $6,000 worth of heating materials. A big order in those days. They had to be designed and made one at a time. Something had been kindled in that first small furnace, and it was beginning to grow.
Just a minute. I keep thinking about this in terms of my own life. Seems strange to think about building the United States with valves and pipe. Of course, they're essential, all right.
The pioneers not only had to learn how to make them, but to mass produce them for the growing industries, which in turn could make the things that pushed up our living standards.
What a time to be alive. I wonder what it feels like to be a pioneer. You know, building a business, growing with the country. Take Crane, for instance. I wonder what he thought about all this.
Well, let's see. It's 1871, just after the Chicago fire. Incidentally, some engines he built pumped water for the city after the fire. The demand for his products is so great that his company has grown until there are 800 employees.
Hey, that's a real jet pace.
Right you are, Bob. But let's find out what he's thinking about.
Power.
You're thinking about power?
Yes. Power and pipe. You see, when I was a boy, an industry had to be located along a river. The river turned a water wheel and supplied power. The river with canals supplied transportation. Now, with the steam engine, we can put power on iron rails and go clear across the country. We can have power anywhere. Develop our natural resources, expand our old industries, build new ones. And behind every one of these developments is a better and better supply of piping materials, of valves and fittings. You see, I learned long ago that no man is alone. Industry cannot live in a separate compartment by itself. The things I was making were more basic than raw materials. The very products that make industry possible. But it meant studying all lines of industry. learning their requirements at any given time, anticipating their future requirements, developing material and methods for the things that were to come. Yes, we all were doing the same thing. We all were building America. No, no man works alone. Real history is no more than a record of how we work together. Somebody digs an oil well in Pennsylvania, drives a golden spike out in Utah territory, learns how to process foods. It's all part of the larger story. And there's a human side, too. Working conditions must be improved, made safer. Medical services must be available, right in our foundries and our factories. Young man, there's so much to do. So much responsibility. But what an opportunity.
R.T. Crane was only one man, but a man with a creed of honesty and fair dealing. A man with enough vision to know what was needed, enough skill and enterprise to start producing the things that were essential to a growing nation. A man of hard work and high principles. By the way, Bob, have you ever seen the Statue of Liberty?
Yeah, from the air.
It was erected in 1886, and it's a good symbol of what we're talking about. This is a country where people can work together, can share the clear light of liberty and great industry. People with a great opportunity to make America grow. Humble beginnings, a homemade foundry about the size of any blacksmith shop. Begun by a man whose name, after 100 years, stands for a company that is the largest manufacturer of valves and fittings in the world, and one of the leading manufacturers of plumbing fixtures and heating equipment. A company that is still growing, still changing to keep up with changing times, developing in many diversified fields, anticipating the new needs of tomorrow. From Chicago, valves, fittings, fabricated piping, plumbing brass and accessories, porcelain enamel plumbing fixtures, heating products, boilers and radiators from Chattanooga. From Trenton, New Jersey and Colton, California, vitreous china plumbing fixtures. From Burbank, California, the newest aircraft accessory equipment. From Maumee, Ohio, steel kitchen cabinets. 7 great plants in Canada, the leading manufacturers of valves, fittings, plumbing and heating equipment. Across the Atlantic at Ipswich, England, another great plant produces valves, fittings and heating equipment. The first branch house appeared in Omaha in 1885. Today, there are branch offices all over the United States and Canada. Hundreds of wholesalers and thousands of retail dealers, serving the needs of every community.
Yeah, they've come a long way from that first foundry. They're big. They're part of a big country. But just being big, is that anything?
It is if you want people to have better food, better shelter, better standards of everything that people need and want. That's why men dream the big dreams and think of the progress they've made. Ever since the first pioneering steps, Bob, they've been working continuously, year after year, to study, to question everything. They work in basic research, applied research. They set standards and raise standards. They meet new problems. They control every step from raw materials all the way through to finished products in daily use. The design, like the production of anything, starts on a drawing board and is controlled all the way. see, even the potter's ancient art can be controlled and mechanized. Or take a modern foundry. That's a good example, Bob, of progress. Power-driven machines and conveyors take over. We've come a long way from that first little foundry. Now the work moves to the man, not the man to the work. Furthermore, we no longer have to design a product that must be built within the limitations of yesterday's machines. Now we design a product as we want it to be, then go ahead and build it. In other words, Bob, along with our scientific controls and our mechanization, machines have been developed to fit the job to be done, instead of designing the job to fit the machine. You talked about the limitations of trying to make things with your bare hands. The first Mr. Crane did 95% of the physical work himself. Today, Bob, machines do 95% of the work and do things that human eyes and hands could never do. Many a pioneering dream has been engineered into routine practice. Just think of how much we've learned. Think of how we've grown. Think of the great changes within the life of this one company. And along the way, and not incidentally, working conditions have been improved. And the comfort and welfare of the multitude of homeowners. But this way, the customer can go to one source and find and buy what he needs. In this country, in Canada, in England, practically everywhere.
That's quite a story, quite a century. Just how many different things do they make?
About 40,000 items.
40,000?
That's just from yesterday to today. From now on, there'll be a lot of new things coming.
Such as what?
Well, fundamentally, this company has worked and is still working to master the science of metallurgy, to learn how to control the flow of water and steam, chemicals and acids at ever-increasing temperatures and pressures. But each new day brings new challenges, new problems in pressure, corrosion, and temperatures. Each new challenge calls for change, improvement, and discovery. Now they're learning to control the production of a new metal, titanium. This meant planning and building something new and unique, a completely integrated titanium plant capable of producing thousands of tons of titanium. For this metal can only be produced in a completely enclosed system, away from air, and under a blanket of inert gases or a high vacuum. Titanium, available in large quantities, will solve many aircraft and marine problems, find wide uses because of its strength-weight ratio, its corrosion resistance. This is pioneering in a new century, building something new, working into the unknown. Near the administration building are the control plants and the finest possible laboratory. Then the great production units, the service and maintenance areas, and the raw materials. Titanium base alloys are extremely strong, far stronger than aluminum alloys, lighter and superior even to most alloy steels. The ore is found in strange-sounding minerals like rutile and ilmenite. To supply part of the raw materials for this new plant, they have searched for deposits of rich minerals and entered still another new field, mining the earth for titanium-bearing ores and rare, heavy minerals, using a mechanical water separation process to control and assure a steady supply of raw materials. Chemistry and electronics are opening the doors of the future. On the West Coast, at Burbank, California, new materials are being engineered and built for the world of tomorrow. These intricate transistors are really a tiny new kind of valve, replacing the old vacuum tubes of yesterday. They're testing new turbine systems for our newest supersonic jet fighters, a mechanical miracle of air conditioning and pressurization. The newest equipment can test temperatures and pressures far beyond those encountered by today's aircraft. This is designed for the higher requirements of the future. Every fighter, every bomber, every transport that flies today carries some sort of equipment made by this company. Not only do they produce and use a metal and build components that make supersonic flight possible, they build a new braking system, highly complicated but simple to operate. A system able to stop heavy bombers or transports, stop them smoothly and safely, even on icy, slippery fields. This is the kind of growth, the kind of planning and progress worth talking about. Just for a moment, think of a single plane. Metal, mechanisms, component parts, even the tiny transistors. These are examples of what we've learned to make. Or take a modern atomic submarine. Like any ship, it's an orderly maze of very special valves and pipe and other products. And they're just as essential in anything else you can think of. A modern skyscraper, for example, or any modern community with its homes and schools and institutions. One good example is a modern hospital. Without these things we've learned to make, you couldn't apply modern medical knowledge or modern techniques. Think of your own son, Bob, breathing conditioned, filtered air, protected against the diseases that were so common, so deadly 100 years ago, even 50 or 25 years ago. And Bob, just think of Anne, and something as simple as a glass of water. Water you can be certain is pure. And when you take Anne home from the hospital, what about your automobile? You expect to buy gas and oil just around the next corner, and you can. You depend on the petroleum industry for these things, just as they, in turn, depend upon the basic products we're talking about. Without them, there would be no petroleum industry, or any other industry for that matter. They make possible the food industry, canned foods, frozen food. Piping and valves are essential to so many industries. The chemical industry, pharmaceuticals, modern medicine depends on them. Let's make this more personal. Think about your own home. Like every industry, every institution, you're served by an unseen network of pipe and valves. Take something as simple as paper. Behind it is still another industry. Great paper mills that couldn't function without these essential products. We take so much for granted. Think of the advances in today's living. We're around with modern baseboard radiant heating for comfort when it's cold, and with controlled air conditioning for the summer months. Behind every modern convenience, you find these same basic things. We don't think much about electricity, but there it is. Behind that switch is a great public utility, great power plants that are a maze of essential piping material and valves. Bob, these products serve at the very heart of our industrial civilization, a heart which is kept alive, like the heritage which made it possible, by people. The thousands and thousands of men and women who have worked together to pioneer our progress are still working together, still pioneering. People who work in these plants, people who save and invest in our productive economy, people who can change with changing times. People, all of us together, for this is how we grow, a company or a nation, changing with the changing times, learning, growing, building America, rebuilding a better, stronger America up from the endless yesterdays into the infinite tomorrows.
Say, what about tomorrow? I know we're into a lot of new things, but can we keep going, or for that matter, keep growing? What about the second 100 years?
The second 100 years?
Joe. Come on, Joe, have fun. Hey, you guys, wait for me.
The second 100 years? Why, with our heritage, our opportunities, we've just started.